Hey guys, how's it going? So what we're going to be taking a look at today is function notation. So we are continuing with what we learned about yesterday, a little bit about functions and what they are, and now we're going to follow it up with how we can show what a function is, or actually write the proper notation of a function with the correct um, vocabulary and with the right type of notation. So let's recap a little bit. So a function, as we talked about yesterday, all it is a relation that satisfies not only the criteria of a relation, but also the criteria of having unique x values in the domain. All that means is there's no repeats in our x values when we list all of our domain values. And it also means that it passes the vertical line test. And all that is if we have a graph of a particular relation and every single vertical line you draw on there only crosses at most one point on the graph, then we have something that is a function. Okay, so that was just a quick recap of what a function is. So let's go ahead and look at a little bit of its. So you guys might have seen or remembered this notation right here. This we say in words f of x. Okay, another way of actually saying this is f is a function of x. Okay, and all that really is that if we have some sort of equation, okay, to represent a graph or a relation, then that particular equation is actually a function of x, meaning that if it satisfies the criteria of being a function, then all of the input values, so all of my x values, will go through this function to turn into y values. So just to actually pick that up a little bit further, I actually write a quick equation here. So I have y equals 3x plus 2. All right? So regular equation, but what I'm going to do now is actually draw what that equation would look like if we were to graph it. So if we were to graph it, this is what the graph would look like. It would look like a straight line, and we would test out to see if it's a function. So we would actually draw a few vertical lines here, and we notice each time it only crosses once on that red function line or that red relation. Okay, so that means it qualifies now as excuse me, it qualifies now as a function. So instead of writing a y here, I'm actually going to go ahead and represent that equation now as a function by writing f of x equals 3x plus 2. So one quick thing to note here, guys, is that this was just replaced by the f of x. So the y was replaced by the f of x. So here off to the side, I'm actually going to go ahead and whoops, f of x represents y. So again, if the equation satisfies if it satisfies the criteria of being a function, then we can say that f of x represents y. Also, that f of x equals y. So again, if it satisfies all the criteria, then we can say that f of x equals y. And I want you guys to remember that because we're going to need that later on in these notes. Okay, so let's go ahead and talk about how we can evaluate a function for a given x value. So if we have an x value and we put it through our function, we're going to get out a y value, so our y coordinate of that ordered pair. All right, so let's talk about a few of the steps that we have to go through in order to find this result. Okay, so in order to find this particular y value, so the first thing we have to do is substitute the x value into the function. So off to the side here, I have a quick example that we can use. So right off the bat, I can tell you that this is our function. Notice right away, I have an h of x. As soon as you see that, h of x, g of x, f of x, okay, you could use multiple letters for the beginning, but notice it's always a function of x. So this is my function. So go ahead and write that down, guys. So that is my function. And now what we're being asked to do is to substitute the x values into that function. Well, what x value do I have here? Well, the x value that I have is a negative 4. All right? So what do I have to do? Well, what's being asked? It says to substitute in that value into my x values, into the function, right? And I notice right away here that I actually have two x values. So when I rewrite this equation, or now this function, I should say, I'm going to write h of negative 4 equals 1/2, and then another negative 4 squared minus 5. So let me just recap what I did there. I know I have to substitute in that negative 4 wherever I see an x, so I put it in here. But there's also an x right there, so I'm also going to put a negative 4 there. So let's continue now with step 2. So we have officially done step 1 is done. All right. Now it says simplify if necessary using PEMDAS. So we have to do any parentheses or exponents first. So parentheses, we see right here, we have a negative 4, but there's nothing in there that we can actually do, so we have to move on to exponents. So we have to raise that negative 4 to the second power. So this really gives us 1/2 times, well, negative 4 squared is 16, and then minus 5. All right, so we got rid of any parentheses, exponents. Next up is multiplication and division. All right, so we're going to go ahead and do that. Well, I see a multiplication there. 1/2 times 16 is actually 8. And I'm going to drop down the minus 5. So I get 8 minus 5, that is just a 3. Now, on this left-hand side, guys, you have to keep that all the way down. So this is h of negative 4 equals 3. So this right here would be your final answer. And you can actually write that in right here. H of negative 4 equals 3. That's what I meant here on the side, guys, by be sure to use proper notation. Don't just give me 3 as an answer. You actually have to tell me all of this. H of negative 4 equals 3. Okay, that is proper notation. All right, guys, so what did we have? Like I said earlier, we had an x value. We substituted into our equation, or into our function rather, and then out came a y value, or a result. Okay, and I want you to keep that in mind because we're going to need that a little bit later. So let's go ahead and try out a few more problems. So it says for number 1 through 6, evaluate the following functions for the given domain values. All right, so the first one that I see right away is f of negative 6. Well, I see an f, so where is that function? Well, it's the one all the way to the left. But instead of an x, I'm looking for this particular value, which is a negative 6. So I'm actually going to go ahead and do that here. F of negative 6 equals, now, where do I see another x in my function of f? It's right there. So I substituted it in there already. That's this one. But now I have to write 1/3, and instead of an x, I'm going to put a negative 6 minus 8. So that was my first step, and now I am done with my step number 1. Substituted in that x value into the function. Okay, now let's actually use PEMDAS to continue solving for the rest of it. So 1/3 times negative 6, that's a negative 2. Again, remember, 1 times negative 6, that's negative 6. divided by 3, that's negative 2. So now I have negative 2 minus 8. So I have a negative 10. So, whoops, let me erase that real quick. If I can find my eraser, here we go. So f of negative 6 equals negative 10. So here, negative 10 equals my f of negative 6. So I found my value. Okay, this is my final answer here. Okay, so next one, g of 3. Well, g is right up here. That's the function I'm going to be using. But wherever I see an x, right, wherever I see an x, instead of writing an x there, I'm actually going to write a 3. So let's go ahead and write down this new problem. So we have, let me use a different color here. So we have g of 3 equals, well, let's see, negative 2. Wait, I see an x there, so let's put a parentheses and in a 3 squared plus 5. Again, another x right there. So I'm going to put another 3 minus 1. So again, guys, compare these two right here. So let's compare. Whoops, sorry about that. Let's use the pen tool here. If I compare this with this, the exact same thing. The only difference is I'm actually substituting in a 3 for all my x's. Okay, go ahead and use PEMDAS now. So I have to use do my exponents first. So 3 squared, that's actually a 9. Okay, so that was the first thing I did. Now I do multiplication and division. So I see two sets of multiplication here. I have one multiplication here and one there. So I'm going to go ahead and actually do them both at the same time. Whoops. So what do I get? I get negative 2 times 9. That's a negative 18. 5 times 3 is a positive 15 minus 1. So negative 18 plus 15 is a negative 3, minus 1 is a negative 4. So my final answer is right here. G of 3 is negative 4. So I'm going to go ahead and write that in for my final answer. All right. So hopefully this is starting to make a little bit of sense, but if not, just go ahead and pause the video or stop it for a second, go back to the previous examples and make sure it makes sense before you keep going. Okay, I'm going to do 2 more with you, and then I'm going to have you guys try 2 on your own. So let's take a look at the next one. Well, I see an h here, so I'm going to use this one right here. I'm going to use h of x. But instead of writing an x, I'm going to write a negative 1. Actually, let me scoot up here a little bit. So I get h of negative 1 equals, well, there's a 1/2. And then instead of an x, I'm going to substitute in, let me use my highlighter here so you guys can see it. Instead of an x, I'm going to put in a negative 1. So here, I'm going to do a negative 1. All right? Well, do you guys still remember this? But 1/2 to the negative 1 power, whenever you raise something to the power of 1, it's the same number. So 1/2 to the 1 would just be 1/2. The difference here is that we have a negative 1, and all that means is that we have to take the reciprocal of that. So what's the reciprocal of 1/2? That's just 2 over 1, which is just 2. Okay? Or if you want to go ahead and use your calculator, go ahead and type it in as 1/2 raised to the negative 1, and you'll notice you're going to get 2 as an answer. Okay, so this right here is your final answer. So go ahead and write it up top on your line. So what we're doing here, guys, is just substituting in an x value and finding its corresponding y value using the function. Okay, Let's do this last one, number 4, and then I'm going to have you guys try the rest on your own. Actually, I got to scoot back up here. So this is h of 3, but instead of an x, I'm going to use a 3 now. So this is going to be 1/2 raised to the 3. So why don't you guys go ahead and type that into your calculators right now, and you should end up with 1/8. So hopefully you guys got 1/8 for your answer. Okay, so go ahead and write that as your final answer there. Okay, so what I want you guys to do is pause the video now for a second and try numbers 5 and 6 on your own. Alright guys, let's go ahead and take a quick look at number 5 together. So we have, let's see, we have f of 24. So I'm definitely using that first function, the f of x function. So I have f of 24 equals 1/3, but instead of an x, what am I using? I'm using a 24. Then I subtract 8. Okay, now I can go ahead and do the second step, which was just use PEMDAS. So 1/3 of 24, that's just 8 minus 8. So 8 minus 8 is just 0. So f of 24 is just 0. And that's an okay answer, guys. Don't think just because it's 0, it's got to be wrong. No, not at all. We can have an answer of 0. All right, so number 6, last one, was g of x. So I'm going to be using my function g. So again, if it helps, go ahead and rewrite the entire equation except for leave a few parentheses wherever you see an x. So that's what I like to do. So I'm going to actually go ahead and write -2 parentheses squared plus 5 parentheses minus 1. Okay, but I do know what I have to substitute into each of those parentheses. We have to substitute in a -4. So let's multiply it out. So first things first, I do PEMDAS, so I have to do the parentheses first. So -4 squared is a positive 16. Okay, so that's a positive 16. And I'm just going to go ahead and rewrite everything else. So I see 2 sets of multiplication here, guys. I see the -2 times 16 and the 5 times -4. Okay, so I'm going to actually do both of them at the same time. I get -2 times 16, that's -32. 5 times -4 is a -20. And finally, I have a -1. So if I subtract all of that, I get -32 minus 20 minus 1. That should be a -53. And actually, I should probably write it like this. G of -4 equals -53. Okay? So write that in for your final answer, and we are good to go. All right. So let's go ahead and take a look at 7 through 12. Now, these are a little bit different, guys. Remember and keep in mind what I said earlier, and I'm going to go ahead and write it off here to the side for you guys. If we know that an equation or a relation is a function, then we can state that f of x equals y. So keep that in mind, guys. Now, according to that, then I'm going to actually go ahead and write this right above it. Okay? So what does that mean? Well, let's take a quick look at it. So that means here, my x value is -1. Well, what is my y value when x is -1? So let's actually look for it. So I'm going to go on my graph to -1. So left 1. Whoops, sorry about that. I'm going to go left 1, which is here. But I'm not on my graph. I need to be on this graph right here. And hopefully I can highlight it for you guys. I need to be on this graph right here. So what do I have to do? Well, I have to look for it. So do I have to go up or down? Well, I have to go up, and I had to go up exactly 1. So if you guys remember, the y-axis goes up and down, and if it goes up it's in the positive direction. If it goes down, it's in the negative direction. So if I went up 1, then my y value has to be 1. Okay? Again, let's do a few more examples and actually figure out to see if this makes sense. So, just like before, this is b of x equals y. So I already know my x value. That has to be 3. So now I have to find my y value. What is my y value? Well, let's take a look at our graph. So if x is 3, that means I'm going to go to the right 3. So 1, 2, 3. And then I have to look for my graph. Well, actually, in this one, the graph is already on the point that I'm at. So how much did I go up or down? Well, nothing. I didn't go up or down. So you would just write my y equals 0. Okay? All right, now for this last one, again, if it helps, go ahead and write it above it, guys. H of x equals y. Remember this all the time, guys. If it satisfies our criteria for our function, then we can write that statement right there. So we know what our x value is. Our x is 0. So what is our y value? Well, let's check it out. Let's take a look at the graph. If x is 0, I don't go left or right, so I'm staying here, but now I have to look for my graph. Well, it's not down here, it's right up here. So what is my y value there? Well, my y value is just 1. Okay, so now, again, even if this, for some reason, is still not clear, guys, how about I ask you guys this? Going back to number 7, what's the ordered pair of the point I just found? Well, that's -1, 1. Well, hey, look at that. If I write this into an ordered pair, that's -1, 1. My x and my y value. My x and my y value. Again, if I write this as an ordered pair, that's 3, 0. Well, this is 3, 0. If I write this one as an ordered pair, that's 0, 1. This is 0, 1. So again, guys, you guys have multiple ways of solving this and trying to understand this. So make sure you pause the video or stop if you guys are confused at all. Okay? Make sure you understand this before you move on. Okay? But let's go ahead now and practice a little bit more using that information. So, once again, I'm going to write my little original statement here. I know my x, it's -2, and my y is what I'm looking for. So let's go ahead and find it on the graph. So if I go -2 on my x, so 1, 2, I have to go up or down. Well, my graph is up here, so I have to go up. So what y value is that? Well, this is, again, the order pair -2, comma. I went up 1, so a +1. So my answer here has to be a +1. All right, next one. I'm going to write my statement up top. And again, you don't have to do that every time, but if it helps, you're more than welcome to try it out and actually use it. So I know my x. Now I'm just looking for my y. Let's figure out what the y is. So if I go to the right one, okay, I'm right here. So I have to go up or down. Well, I go down to find my graph. In this case, my order pair is 1, comma, and I went down, so I went down -1. So my answer here is a -1. Okay. go ahead and pause the video for a second, guys. I want you guys to try out number 12 on your own, and let's go ahead and confirm that you got it correct. All right, guys, let's go ahead and take a quick look at number 12. So let's see. My original statement is this because I know it's already a function. It does pass the vertical line test, guys. Okay, so we're going to actually identify what our x value is first. So my x is -3, but I'm looking for my y value. So let's take a look at our graph. If I go to the left 3, so I go 1, 2, 3. Okay, now where's my graph? Is it up here? No, it's not up there. It's down here. Right there. So what is that ordered pair? That's -3. And I also went down 3, so that's another -3. So my final answer here is -3. Alright, guys. So hopefully that made a little bit more sense now that we got a chance to try out a few. And now we can move on to the last part of today. So the last section that we have here is operations with functions. So we can actually go ahead and add, multiply, subtract, and divide functions, okay? But right now we're actually just going to focus on addition, subtraction, and multiplication. But we're going to go ahead and use these functions up here, okay, in order to help us solve these operations. Okay, so I just highlighted them different colors so it's a little easier to identify what we have to do here first. Alright, so what do I have to do for the addition problem? Well, it says I have to add the f of x plus the g of x, which is the green one. So that's exactly what I'm going to do. I'm going to go ahead and write what f of x is. It's right here. So I'm going to go ahead and write f of x as 3x squared minus 2x plus 8. Now I have a plus. I'm going to do a plus. Okay. All right. So plus g of x, which is x squared minus 7x plus 1. Okay. So I'm adding those two functions, guys. All of f of x is this, and all of g of x is this. Okay. Now, this is where you have to be careful. Not so much with addition, but definitely with subtraction, guys. So, notice how I encapsulated and I put all of f of x in one parenthesis and all of g of x in another parenthesis. The reason I'm doing that is because we're going to have to do that for subtraction because you're going to have to distribute something here that you might not have otherwise done had you not had those parentheses. So, let me ask you this. In front of this first set of parentheses here, well, there's no number there. I mean, if we could, or if we wanted to, we could say that there's a 1 there. But if I distribute a 1, what's going to happen? I'm going to get the exact same thing. I'm going to get 3x squared minus 2x plus 8. Okay? Then I'm going to have plus, and once again, I have another 1 right here in front of the parentheses. So if I distribute, once again, I'm going to get the exact same thing. Because 1 times any number is just that exact same number. Okay? But get in the habit of putting it in parentheses, guys, if you need to remember it. Because it can be very confusing for subtraction and can lead to the wrong answer if you forget to distribute. Okay? So, once I have all of this, this is just an expression now, okay? And I can combine like terms now, just like we've done before. So, go ahead and start adding, or combining rather, the larger variable terms, and then work your way down until you hit the constant terms. So right away here I see an x squared term and another x squared term. I see a x term and an x term. And finally I see a constant term. There and there. Alright, so the first one I'm going to do is the x squareds. Remember, right here in front of the 1 there is, I'm sorry, in front of the x squared there's a 1. So 3x squared plus 1x squared is 4x squared. Negative 2x minus 7x is negative 9x. And negative 8 plus 1 is a negative 7. All right. So what did I do? Again, let's recap. It's always nice to go ahead and look back at what we did and recap what we did. All I did was write all of f of x in one parentheses. Then I added, because that's what we're doing addition. We're adding all of g of x, and all of g of x is right here. So I put that in parentheses. Okay? Now, outside of those parentheses would be a 1, so even if you distributed a 1, you'll end up with the same answer. So we can basically get rid of the parentheses for addition. And then all we did was combine like terms. And when we did that, we ended up with 4x squared minus 9x minus 7. Okay? All right. Now, oh, actually, I think I might have written something wrong here. I'm just catching that now, so if you made that mistake, you're not the only one. So this right here should actually be a positive, if I'm not mistaken. This should be a positive 8. Whoops. Sorry about that, guys. That should be a positive 8, which actually makes my answer a positive 9. So I'm just catching that